Hello Applied Math students. This video is for our Math on the Moon project phase 3 analysis. Okay, now that your mission team has gathered data and have determined what you feel is the minimum distance and minimum time for the crew to use for this mission, you'll submit your calculations for review. In phase 3 here, you'll compare your answers with the actual minimum distance and minimum time, and we'll see how accurate your findings actually are. So what did your mission team conclude to be the minimum distance for this mission? Please fill this in on your paper. Write your answers in ordered pair with the end value and the minimum distance. For example, mine, I used the point at 12, and my minimum distance was 49.30. Okay, using the formula you discovered in phase 1, that's the very last row of your table for phase 1, we can find the absolute minimum distance. This should be the formula that you found. Well, this is an equation, and we can plug this into Desmos. And if we plug this into Desmos, we get a shape that is a parabola. And if you remember about parabolas, they have a vertex, which is a minimum point. And this right here is the actual lowest, this is the minimum point for this formula at 11.901, 49.308. So if you got something that was lower than that, you probably did something wrong on your math. Because this is the absolute lowest minimum distance that we can get. So analyze, how does the minimum distance found here in the graph compare to what your team computed as the minimum distance for the mission? Explain your thoughts. Pause the video, do that. After you've done that, then let's analyze phase 2. What did your mission team conclude to be the minimum time for this mission? Write your answers in ordered pair with your end value and your minimum time. This might not be the same thing as your minimum distance. It might be the same thing, but it might not, and that's okay if it's not. Well, using the formula you discovered in phase 2, you can find the absolute minimum time. This should be the formula that you found in phase 2, and we can enter this into Desmos. And when we do, we get another parabola, and it has a minimum value, and this right here is the minimum value for that, 14.143, 6.789 at this point along the crater, and this would be our minimum time in hours, 6.79 hours. So how does the minimum time found here in the graph compare to what your team computed as the minimum time for the mission? Explain your thoughts. And after you have finished that, do an overall analysis. Now that you've determined both a minimum distance and a minimum time, what point would your mission team consider to be the best choice to travel so that both the distance and time are minimized? Express your reasoning. Maybe you think the best point to choose is the one that has the minimum distance. Maybe you think it's the one that has the minimum time. Maybe you think it's somewhere in between. Maybe you think it's something completely different. There's not a set right answer for it. Whatever you say, just express your reasoning using some complete sentences. I hope that you found this project to be interesting and an actual application of when we use these things. Make sure to put all of your group members' names on your packet and make sure that you have completed everything. You've done all the tables and you have used colors and you have answered all the questions, and then make sure to turn it in to me. Thanks.